Hello students, welcome back to the sixth video of this playlist. In this video, we will be solving question number 6 from the recent past paper of Pure Mathematics 2, which is the May 2024 P2 paper. So let's get started with question number 6. So at first, part A. So here the question is asking to sketch the curve with equation y equals to a to the power x plus 4, where a is a positive constant greater than 1. On your sketch, show the coordinates of the point of intersection of the curve with the y-axis, the equation of the asymptote of the curve. So basically we need to sketch this exponential curve. Okay, so a to the power x plus 4. So basically, did they give x's? Okay, they have given some blank space to sketch this. Okay, so let's have a look on here. That's enough space. Okay, part A, we need to sketch y equals to a to the power x plus 4. So let me draw the axis at first. This is the vertical y-axis and this is the x-axis. Okay, so basically for the curve in the form y equals to a to the power x, these curves are like this, isn't it? Like this. But here, so asymptote, the horizontal asymptote, we know that exponential curves never reaches the x-axis. So x-axis is the asymptote for this exponential curve. So x-axis, at x-axis it is y equals to 0. But here it is a to the power x plus 4. That means the curve will be moved along the positive y-axis by 4 units, and therefore the asymptote, the horizontal asymptote, will also get moved along the positive y-axis by 4 units. So instead of the x-axis, it will be a bit 4 units above. Okay, so and the curve would be it is a to the power x plus 4. Like this, it will go like this. So this is y equals to a to the power x plus 4. This is the y-axis y, this is the x-axis x prime. Okay, and the asymptote is at y equals to 4. It has moved along the y-axis by 4, positive y-axis by 4 units, and the y-intercept, if you put x equals to 0 there, a to the power 0, it is 1, so 1 plus 4 is 5. So x is 0, y value is 5. This is the y-intercept. That's it. This is the sketch of the curve y equals to a to the power x plus 4. Fine. Okay, next is part B. In part B, the question says the table shows corresponding values of x and y for y equals to 2 to the power x negative twice of x. So here we can see a table of values for x and y for this equation y equals to 2 to the power x negative twice of x, with the values of y given to 4 decimal places as appropriate. Okay, using the Trapezium rule with all the values of y in the given table, part B is asking to obtain an estimate for integration of 2 to the power x negative twice of x from x equals to 2 to 3.5, x equals to 3.5 with respect to dx, giving your answer to 2 decimal places. So we need to find out the value for this integral, this definite integral, using the Trapezium rule. So basically the formula for Trapezium rule, it will be given in the formula booklet, so no worries there. The formula for the formula, okay, Trapezium rule, it's not given. Okay, wait, I think it's given in the next page. Yeah, in the numerical integration it is given. Okay, I couldn't see this, so it's basically given here, the Trapezium rule. Half of h is basically the distance between the strips. So this is basically the distance between the y values. So the difference of the x values. This is h is constant, so this is the difference of the x values. Y0 is the first strip and yn is the last strip, the height of the last strip, and y0 is the height of the first strip. Okay, and y1, y2, y3, it goes the next strip of the first one. So we will add the first strip and the height of the first strip and the last strip separately within the bracket. Okay, let's have a look. If I do it, you can easily understand. Area using the trapezium rule. Okay, area, it is equals to half of h. H is the width of the strips, so this is basically the difference in the x values. It is constant. Okay, it is here 2.3 minus 2, which is 0.3. so this is 0.3 times the height of the first strip, which is here, it is 0, and the last strip, it is 4.3137 plus twice of the remaining strips, which is 0.3246 plus 0.8629 plus 1.6643 and at last it is basically 2.7896. Now close the bracket. That's it. Now just calculate using your calculator. You will get the value. So 0.3246 plus 0.8629 plus 1.6643 plus 2.7896. I'm adding the values within the first bracket and then multiply it by 2 and then add 4.3137 times 0.3 times half. So that would give you 2.339475. Okay, so 2.33, okay, 2.33, okay, 33947, okay, 339,475. So the question has asked up to how many significant figures? Okay, to 2 decimal places. Okay, we need to give the answer to 2 decimal places. So we can say it is 2.34 up to 2 decimal places. That's it. That's what part B of question number 6 has asked for. Fine. Okay, next is part C. So part C1 at first. So here the question says, using your answer to part B and making your method clear, estimate in part 1 integration from x equals to 2 to x equals to 3.5 of 2 to the power x plus twice of x dx. Okay, we need to find out the integration of this integral, definite integral. Okay, so the question says using the answer of part B. So in part B we got the value for integration of 2 to the power x minus twice of x, but here it is plus twice of x. Okay, so let's use the answer of part B to approach this answer. So from part B we got integration. Okay, it was not supposed to be the area, it is basically integral. So integration from 2 to 3.5, the equation, this equation was 2 to the power x minus twice of x dx. This is equals that. Okay, please correct it out. So for part C1, integration of 2 to the power x from 2 to 3.5 dx minus, I'm just separating the integral, so 2 integration to 3.5 x dx, it is equals to 2.339475. okay, so let's figure out the value for integration from 2 to 3.5 2 to the power x dx. It is equal to 2.339475 plus 2 times integration of x, so it is basically half of x squared. okay, in integration we add 1 with the power, so it was x to the power 1, so 1 plus 1 it becomes x squared. Then use the new power to divide the coefficient. The coefficient was 1, so 1 over 2, it is what, half. So upper limit is 3.5, lower limit is 2. Now get the value for integration from 2 to 3.5 2 to the power x dx. So that would give you half of x squared, so half times 3.5 squared, the upper limit, minus half of 2 squared, which is 4, times the, in the outside we can see there is a multiple 2, so times 2 plus 2.339475, so that would give you 10 point, this is 10.58947.5. so we got the value for integration of 2 to the power x from x equals to 2 to x equals to 3.5. Now in part C1 they are asking for the integration from 2 to 3.5 for 2 to the power x plus twice of x dx. So this can be written as 2 to 3.5 2 to the power x dx plus 2 integration to 3.5 x dx. Fine. okay, so here what we can put the value for this one. We got 10.58947.5 plus 2 times same as before, half of x squared, upper limit is 3.5, lower limit is 2, so you will get half of x squared, so half of 3.5 squared minus half of 4 times 2, so which is 33 over 4 plus 10.58947.5, so this is basically 18.839475. so we need to give the answer to how many significant figures? okay, let's write it to 3 significant figures. okay, so we can write it as 18.8. that's it. That's the answer for part C1. Fine. okay, next is part C2. Here the question is asking to find the value for the integration of 2 to the power x plus 1 minus 4x dx from x equals to 2 to x equals to 3.5. okay, so 2 to the power x plus 1, negative 4x. okay, so 2 to the power x plus 1, this can be written as, okay, let me write it down on the next page. For part 2 the question is asking to find the integration 2 to 3.5 2 to the power x plus 1, so 2 to the power x plus 1 can be written as 2 times 2 to the power x, and then they are writing here it is negative 4x, so negative 4x can be written as negative 2 times 2x dx. that's it. So from there we can take 2 common. If you take 2 common you will get 2 to the power x minus twice of x dx, And now we know the value for this integration, this integral, this definite integral, that was in part B. We got this in part B, which is 2.339475. So 2.339475. 339475. So the value would be 2 times 2.339475. So that would give you 4.67895. So up to 3 significant figures, we can write 4.68. That's the answer for part C2. And that's the end of question number 6. Fine.